afternoon, and we're looking at some exercises and experimentation that can help students to understand heat flow, air tightness and ventilation in technical building design. Now, we've set up a very interesting experiment here today. This is called the Schlieren imaging approach, and essentially what we're using is a concave mirror, a beam of light and a camera lens to make the diffraction of light through a column of heated air very visible. Now, I'm joined here by my two wonderful assistants, research assistants, Vic and Z. Hi guys, thanks very much. Sorry for pulling you away from your project work. But if we look here on the screen, well, first of all, we can see the setup here. We've got the mirror, concave mirror. We have our DLSR, and we've got our light source. And then what we're doing here to demonstrate to the students is we've got a projection screen that's basically pulling up the video image from the camera. Now, let's see what happens here. Vic, go ahead. Now, what you're seeing here is the column of heated air, which is less dense than the air around it, being refracted through the beam of light and the concave mirror. But if we look at what is actually visible, is this. Obviously the column of air is not visible to the naked eye, but it is to this particular Schlieren setup. If we go back to the screen, we can see here that this column of air is incredibly visible. Now, thank you, Vic. And now Z is going to do something similar, but this time with the hairdryer, putting out hot air. Thanks, Z. This is what we can see to the naked eye, not very much. However, on the screen, we can see a very clear column of heated air. Thanks, Z. Excellent. So the idea is that we can take scale models, we can put them in front of the mirror, they're scaled down to 1:20, and we've been exploring air tightness. So how do we make a volume airtight, and how do we demonstrate that it's airtight? How do we validate it and test it? So what we've been doing is putting the hairdryer into the model and pumping the model full of air, turn it off, and we can see the heat escaping. If it is escaping, that's obviously a technical issue. Z has a model here, very simple form, some insulation, some air tightness membrane on the inside. We've been looking at control of water, controlling heat and controlling air. So what Z is going to do is take the heat source. First of all, I can see Z is configuring the position of the model so that we can see the gables in the Schlieren setup. You can see that on our camera as well here. Essentially, we line that up, and then we take that should be okay. Then we take the hairdryer, and we're going to inject some heat, and then close the door and see if the building can hold the heat. If it can't, we're going to see some heat rising from the model, and that's heat loss. Okay, heat source is removed. The door is closed on the model. by Z. And now we can just check to see if anything is still moving. And as you can see here, if you look closely, the model is still losing some heat. So, looks like this group has got to do some work on air tightness and insulation. Thanks guys, bye.
See ya.